In this video, we're going to be looking at how to solve radical equations. Now, the first step in solving a radical equation is to get your radical, square root, cube root, fourth root, whatever it is, isolated by itself on one side. Then you raise each side to the power of the index. Now, what that means is, let's say I have the square root of x. I would raise both sides to the second power. Or if I had the cube root, I would raise both sides to the third power. If it was a fourth root, I'd raise it to the fourth power. This gets rid of the radical and leaves you with an equation. You solve the equation to get your x values. Then you must check for what's called an extraneous solution. Now, an extraneous solution is one that if you were to plug it back into the original equation, it doesn't actually end up working. So let's go ahead and look at some examples. In this example here, the first thing we need to do is get our fourth root of m by itself. And I'm going to do that by adding the fourth root of m to both sides. Now, I could have done this by subtracting 3 and then multiplying by -1, but I'd rather do it in one step. So I get 3 is equal to the fourth root of m. Alright, so the next step is to get rid of the radical. And you do that by raising it to the power of your index. So in this case, that's to the fourth power. So the next step you do is solve whatever equation remains. So 3 to the fourth power gives us 81, and over here all we have is m. Well, in this case there was not an equation left over, it just got us our answer. However, we're not done with this problem, because you always must check your solution. And the way you do that is you take your answer and plug it back into the original problem. So we get 3 minus the fourth root of m, which is 81, equals 0. Well, fourth root of 81 is 3, and 3 minus 3 is 0. It does check out, so that means this is our answer. So let's look at another one. In this one, to isolate a radical, we have to get rid of both the 18 and this -4. Now remember that when solving an equation, you almost go in reverse order of operations. So we're actually going to do our subtraction before our division. So we're going to subtract 18 from both sides to get -4 square root of 43 minus 3x equals -20. Then you divide by -4 to get the square root of 43 minus 3x equals +5. Now we have to square both sides to get 43 minus 3x equals 25. Right. Next step, you subtract 43 from both sides. 25 minus 43 gives us -18, and then you divide both sides by -3 to get +6. Now you must check your answer. So if I do -4 square root of 43 minus 3 times 6 plus 18, I should get -2. And I'm just going to take a shortcut here. -4 times the square root of 43 minus 3 times 6 plus 18 does give me -2. So this one checks out, meaning x minus 6 actually is our answer. Now this next one might look like it's a different type of problem, but it's really not. Because remember that if you see an exponent that's a fraction, you can write it as a radical. So if I have an exponent of half, that's a square root. If I have an exponent of 1/3, that's a cube root. 1/4, that'd be a fourth root. So to solve this one, I'm going to isolate my radical, my c minus 12 to the half power, by dividing both sides by -9. This will give me 4 equals c minus 12 to the half power. The next step, raise each side to the power of our index, which in this case is the denominator of 2. So I'm going to square both sides, which gives me 16 equals c minus 12. add 12 to both sides to get 28 for our C. Now, we do want to double check this. So negative 36 is equal to negative 9 times 28 minus 12 to the half power. So, again, I'm just going to use my calculator real quick, do it all at once. So if I type that in, I'll also get negative 36, which means this checks out, and this is our answer. But what happens if the number doesn't work? Let's take a look at this next problem. Step 1, isolate your radicals. So I'm going to start by adding 9 to both sides. This will give me the fourth root of 8k plus 12 is equal to negative 2. Then I get rid of the radical by raising both sides to the fourth power, which will give me 8k plus 12 is equal to 16. And now I solve for k. So I'll subtract 12 from both sides to get 8k equals 4, divide by 8 to get 1/2. Now, let's plug in this answer to the original equation. I have 8 times 1/2 plus 12, and then fourth root of that, minus 9, hopefully will give me negative 11. Well, that's 4 plus 12 to get 16. Fourth root of 16 is 2, and 2 minus 9 is negative 7. This does not equal, so this is not an answer, which means my answer is actually no solution. Now, a few more problems. This next problem actually has radicals on both sides. Now you'll notice that on both sides, all you have is a cube root with nothing outside of the root. So anytime that happens, so let's say you have square root of x equals square root of y, that means what's underneath is equal. Or if I had the cube root of x equals the cube root of y, x and y would be equal. The reason is, if you raise both sides to the third power in this case, both sides get the cube roots canceled out, giving you just what's under the radical set equal to one another. So, what I'm going to do now is I'm going to move things around. I'm going to add 2d to both sides. I'm going to add 3 to both sides, which will give me 30 equals 3d, which means d is 10. But you must always check your answer. So, if I do this cube root of 27 minus 2 times 10, hopefully it'll end up being equal to the cube root of 10 minus 3. Now, in this case, we get the cube root of 7 equals the cube root of 7. So it checks out, making 10 my answer. Now, on this one, we have radicals on both sides again, but this time there are things outside of the radicals. Now, you have to have the radical isolated on at least one side. So I need to either move the 4 or the 12 over to the other side. In this case, because 12 is divisible by 4, it's the 4 I'm going to move. So I get the square root of 3q plus 15 is equal to 3 square root of q. Now that one of my radicals is isolated, I'm going to square both sides. Now all that does over here is gets rid of the radical, so I have 3q plus 15, but on the other side I have to square both the 3 and the square root of q. 3 squared is 9, square root of q squared is q. So now I solve the equation for q. Subtract 3q from both sides, I'll get 15 equals 6q, and then divide both sides by 6 to get, let's see, that would be 3/2. Wait, no, 5/2, I'm sorry. I'm throwing away. Now, you have to check yourself. So 4, and then 3 times 5 halves plus 15 equals 12 times the square root of 5 halves. Now, this one, I can look at this side and tell it's not going to divide evenly. So what I tend to do when I go to check myself on these is I just do it this way. So 4 times the square root of 3 times 5 halves plus 15. And on this side I get 18.97. The decimal goes on forever. And then on the other side I had 12 times the square root of 5 halves. And if you look, I can see that my decimals are the same, so this does end up being equal. So this is my answer. Alright. Now on this problem, again, you want to start off by isolating one of the radicals. Now technically this one's already isolated. Now, that being said, I tend to prefer working it with everything on the same line. So I'm going to multiply both sides by -2 to get the cube root of 14 minus 10x equals -2 cube root of x. Because it actually, to me, makes things a little bit easier with everything on the same line. So now I'm going to cube both sides to get 14 minus 10x is equal to -8x. Add 10x to both sides to get 14 equals 2x, which means x is equal to 7. Now again, you have to plug this into both sides. So if I plug 7 into this side, I get the cube root of 14 minus, minus 10 times 7, and then divide by -2. Now the other side I have, the fourth root of, or cubed root of 7, and you can see that they're equal. So by plugging these into both sides, I can get the same answer. So that means my answer does check out. Now sometimes when you work these, you're not going to get just one answer. You have more than one possible answer. Like on this next problem. Square root of 8x equals x already has 8x isolated, so I'm going to start off by squaring both sides, which will give me 8x equals x squared. So what I have is a quadratic. Whenever you have a quadratic, almost every method of solving it requires it to be equal to 0. So keep my x squared positive, so I'm going to subtract 8x from both sides. And then I'm going to factor. In this case, the easiest way to factor is take out the GCF, which is x. Then you set each factor equal to 0 and solve. This one is already solved. For this one, you add 8 to both sides, and I get 8. Now, because we have two possible answers, we have to check both answers. So if I do the square root of 8 times 0 equals 0, plug it in, I have to see if it works out. This multiplies to be 0, square root of that is still 0. This one checks out, so 0 is a solution. For the other one, square root of 8 times 8 equals 8. Square root of 8 times 8 is also 8. This checks out. This is also a solution. You must check both solutions before you decide if there's no solution or just one solution. In this case, both of them worked. That doesn't always happen though. Let's look at a couple more. Now this one, this is already isolated. So our next step is to get rid of the radical, in this case by squaring both sides. So I get 6x minus 38 over here, but on the other side, I actually have to FOIL that out or use the box. You actually have to square it. The answer is not m squared plus 25. That is incorrect. You have to square it out using this because it includes these terms. So we get m squared minus 10m plus 25. Now, same as before, if you're solving a quadratic, you want it equal to 0, so I'm going to subtract 6x from both sides. And I just now realized I did not use the same variable on both sides. So we're just going to switch that to an x. And hopefully I'll pay more attention in the future. So subtract 6x from both sides and add 38 to both sides. Alright, so that means this side everything cancels out, giving us 0. Now I've got x squared minus 16x plus 63. Now to factor this, I need two numbers that multiply to be 63, but add to be negative 16. That's going to be negative 9 and negative 7. So this factors to x minus 9 times x minus 7. Now I have to set each factor equal to 0. Minus 7. There we go. And then solve for x. Let me try and write this better. So I get positive 9 and positive 7 as my possible x values. But again, you have to double check both sides. So, square root of 6 times 9 minus 38 equals 9 minus 5. Well, 6 times 9 minus 38 is 16. Square root of that is 4. Over here, I get 4, so x equals 9 is one of my solutions. On the other side, on the other possibility, I have 7. So I'm going to do the square root of 6 times 7 minus 38 equals 7 minus 5. So I'm going to get 2 equals 2, which checks out as well. So both of these were answers. Alright, one more problem to show you that sometimes both answers don't always end up working. The method for solving this one is the same as the previous one. I'm going to start by squaring both sides, which will give me, sorry, let me rewrite that, which will give me 51 minus 5x is equal to, now on the other side what you have to do is you actually have to square both sides. So we have x and negative 11, x and negative 11, that'll give us x squared, negative 11x, negative 11x, and 121. So on this side we get x squared minus 22x plus 121. Now I'm going to subtract 51 from both sides and add 5x to both sides. This gives me 0 equals x squared minus 17x plus 70. So now I need two numbers to factor, two numbers that multiply to be 70 but add to be negative 17, which will be negative 7 and negative 10. Which means when I solve, my two possible answers are positive 7 and positive 10. Now you do have to check both answers. So square root of 51 minus 5 times 7 equals 7 minus 11. So on that side, on the left side, 51 minus 35 gives me 16. Square root of that would be 4. Over here I get negative 4. These are not the same thing, therefore this is not a solution. But it's not necessarily no solution. It's only no solution if neither answer works. So let's check the other one. Square root of 51 minus 5 times 10 equals 10 minus 11. So 51 minus 50 is 1. Square root of that is 1. 10 minus 11 is negative 1. This doesn't work either. And now that both answers have proven to be extraneous, now I can say it is no solution. Now, it is possible for one to work but not the other. So make sure you always check both answers, because it's possible when you work a problem like these last two, you get two answers, one works and one doesn't. So just be careful about that. Alright, that's it for this video. See you next time.